In this video, we are going to prove Pythagorean Theorem trig identities. Here we have sine squared theta plus cosine squared theta is equal to 1. 1 plus cotangent squared theta is equal to cosecant squared theta. Tangent squared theta plus 1 is equal to secant squared theta. And we will prove all three of these identities. It is assumed that you already have an understanding of Pythagorean Theorem, right triangle trigonometry, reciprocal identities, and quotient identities before watching this video. So if you need a little refresher, you can look at the picture coming up on the next slide, pause the video, reflect, and continue. Did you get a good look at it? Great, let's begin. We begin with what we already know. Recall a right triangle. So here we have a right triangle. Here is my 90-degree angle, and here is a given angle theta. We will call this side O for opposite of the angle theta. We will call this side A for adjacent of the angle theta, and we will call this side H for the hypotenuse. Now we know from right triangle trigonometry that sine of an angle theta is equal to opposite over hypotenuse. And we know that cosine of an angle theta is equal to the adjacent side over the hypotenuse. Now, if I were to solve for O and solve for A, we would get H sine of theta is equal to O, and H cosine of theta is equal to A. Now let's put this on the shelf for just a moment, and let's recall Pythagorean Theorem. We know that O squared plus A squared is equal to H squared. So if I take this expression here and plug it in for O, and take this expression here and plug it into A, we would get H sine of theta squared plus H cosine of theta squared is equal to H squared. Now I'm just going to rewrite what I have here. So we have H squared sine squared theta plus H squared cosine squared theta is equal to H squared. Now, if I divide both sides by H squared, we would get sine squared theta plus cosine squared theta is equal to 1. And here we have our first identity. Sine squared theta plus cosine squared theta is equal to 1. Now let us prove the second identity. We will prove the second identity using the first one. So I'm going to come here and I'm going to say sine squared theta plus cosine squared theta is equal to 1. Now if I divide everything through by sine squared theta, we would get sine squared theta divided by sine squared theta plus cosine squared theta divided by sine squared theta is equal to 1 over sine squared theta. And when we do that, we get a cancellation here. So we get 1 plus cosine over sine is cotangent, so we can replace that with cotangent squared theta. And we know that by our reciprocal identity that 1 over sine squared theta is equal to cosecant squared theta. So we have CSC squared theta. And here is our second identity that we have proved here. So now we want to prove the third identity. Again, we will use the first one to prove the third one. So I'm going to start off with sine squared theta plus cosine squared theta is equal to 1. Now, instead of dividing through by sine squared theta, we will divide through by cosine squared theta. So we have sine squared theta over cosine squared theta plus cosine squared theta over cosine squared theta is equal to 1 over cosine squared theta. We know that from our quotient identity that sine squared theta over cosine squared theta is tangent squared theta. So we have tangent squared theta plus, and of course cosine squared theta over cosine squared theta is 1. So we say 1 equal to, and by the reciprocal identity, we know that 1 over cosine squared theta is secant squared theta. So we say secant squared theta. And here is your third identity. Now, you can get variations of the three identities. For example, we can rewrite sine squared theta plus cosine squared theta is equal to 1 as sine squared theta is equal to 1 minus cosine squared theta. We can also rewrite it as cosine squared theta is equal to 1 minus sine squared theta. And here you have two more identities. Similarly, I can rewrite 1 plus cotangent squared theta is equal to CSC squared theta as COT squared theta is equal to CSC squared theta minus 1. It can also be rewritten as CSC squared theta minus COT squared theta is equal to 1. And here we have two more identities. And again, tangent squared theta plus 1 is equal to secant squared theta can be rewritten as secant squared theta minus tan squared theta is equal to 1. It can also be rewritten as tan squared theta is equal to secant squared theta minus 1. And here you have two more identities. And that is how you prove Pythagorean Theorem trig identities. Now you are ready to use these identities to prove more challenging identities. That will be in another video, so stay tuned. Thank you for watching, and always remember that you are awesome.